Okay, everybody, this is section 9.7 on probability. Most of this will probably be a review. The good things to go over, though, again, especially as we're getting ready for MCAs and ACTs and all of that good stuff. But we're going to hit some highlights. There's going to be quite a few pretty quick examples, but I want to talk about all the big ideas in probability and how you calculate that, and odds. So we want to make sure we make the distinction. A lot of people use those words interchangeably, but they are not the same thing. Very closely related, but not the same thing. So we're going to talk about probability and odds, how to find what does mutually exclusive versus inclusive mean, what does independent, dependent, and complements. What can we use for complements to help us solve? So kind of a big overview on probability. All right, so I'm going to give you a chance to jot down a couple important vocab words, and we're going to pause whenever you need to too, so you can jot things down. But if we talk about this just in a general sense, we need some terminology things laid out. So outcomes are all the possible things that can happen, the possible solutions, the things that the different ways something can be done. So if we talk about the outcomes of something, it would be like if we are rolling a die, the outcomes would be the like you could get a 1 or you could get a 3. That would be an outcome. A sample space is all the possible outcomes together. So if they're talking to you about a sample space, it means everything that's possible. So again, if you're rolling a die, it would be that you are looking for either a 1, a 2, a 3, a 4, a 5, or a 6. That would be the sample space. For an event, that's any part of that sample size. So if they talk about if an event occurs, it's like, what's the probability, the likelihood that you roll a 7? The event would be rolling a 7. So you'll hear that. So any part or subset of that sample space. So those are some of the terms you might hear, just so you're familiar with those values. All right, so we're going to be doing a bunch of examples today. So please make sure you pause and jot down the examples. Add posties if you need to, so you get those in there. So first thing we're going to do is just talk about how do you find the sample space. If we're going to calculate a probability, we're always comparing it to how many total ways there are to do something, and that's that sample space. So we need to know what are our total number of options before we start. So understanding what your sample space is kind of that first step. So what's the sample space for a letter is chosen randomly from the alphabet? Well, what are the total number of possibilities, or what are the total number of possibilities? They would be all the letters in the alphabet. So the sample space, and a lot of times they'll just kind of list things so you have it. Sometimes they'll say S for sample space. Sometimes we write it with set notation just to make it a little bit easier. The outcomes are literally all the letters in the alphabet. So I'm not going to write all of them, but we have those. So the sample space is the set of alphabet letters. So there'd be 26 of them total to be able to look at. So we know what our sample space was. What is the sample space for a 6-sided die being tossed for part B? Well, the sample space would be all the different outcomes that are possible. So you could get a 1, a 2, a 3, a 4, a 5, or a 6. That would be your outcome list. So that's your sample space. If you flip a coin and you toss a die, what would be your sample space? Well, you're going to have two different things to keep track of then. So we have to think about what those outcomes could be. So what are your outcomes if you flip a coin? Well, you can either get heads or you can get tails. For the 6-sided die, we know you could get a 1, a 2, a 3, a 4, a 5, or a 6. So what are all the different outcomes that are possible? Well, listing is kind of a nice way to do this. We could get a heads with a 1, a heads with a 2, a heads with a 3, heads with a 4, heads with a 5. So we're heads with a 6, listing our sample space. And then we could get tails with a 1, tails with a 2, tails with a 3, a 4, a 5, or a 6. So our sample space would be these 12 outcomes, right? Those are the only possibilities. So then we could talk about, all right, how likely is it that you get, and then whatever that might be. So in order to be able to find probability, we have to be able to calculate the total number of ways something can happen, that sample space. All right, so let's talk a little bit about probability. I know you know a lot of this background information, but let's make sure we know. Basically, what you're going to look at is how likely is it for something to happen. So we're talking about how likely. You're going to hear that word over and over again. The probability in event, so they're talking about E in event, that just means what are you looking for? The probability of rolling a 7, the 7 would be the event. Basically is a ratio between how you can have a successful outcome to the total number of possibilities. So I always like to think of probability as being, I'm just going to kind of write it in words here. So probability is the ratio of success, so the number of ways you can do something and get the outcome you're looking for, over the total number of ways that event can happen. So the way they're going to write that then, they're going to use P for probability, E for event. Inside there, what I would usually say is the description of what you're trying to look for, and we'll model that. So the probability of something happening then is the number of ways that outcome can happen, so the number of ways the event can happen, to the total number of possibilities in your sample space. So they're using E for the event and S for the sample space. Now, don't get hung up on the labels there. It's just always success to total, the number of ways your outcome can happen to the total number of outcomes that are possible in your sample space. So now let's think about what your limitations are then. The probability of event, when you look at it then, either it can never happen all the way up to it always happens. So when we're looking at kind of our either end, if you have a probability of 0, that means it never happens. And if you have a probability of 1, that means it always happens. And everything else is going to be somewhere in between there. So the probability is 0, that means that event cannot occur. It is physically impossible. Like if you're going to talk about, okay, I'm going to draw or do a 6-sided die. This would be a great example. I'm going to roll with one 6-sided die of 7. Nope, because the die goes 1, 2, 3, 4, 5, 6. There isn't a side that has a 7. That would be a cannot occur. The probability would be 0. If the event can, oh, they would call that then an impossible event. Kind of makes sense. You can imagine what WebAssign is going to say then. Impossible, probably all in capital letters. Very aggressive. If the probability is 1, so we're looking at our kind of our either end here, that means the event always happens. So it's a must occur. It has to. There's no other way it's going to happen. And the event, they would call that it's certain. It is going to happen. This is certainly going to happen. So like if I say I'm going to roll a 6-sided die and I'm going to get a number 1 through 6, yep, every single time. That would be a certain event. All right, so let's probability, success to total. Now let's talk about odds quick. So odds, people use that word interchangeably. Odds is a ratio as well, but it's a ratio of the success, so how many ways an outcome can occur, to the fails, how many ways the event does not occur. So success to failure. So sometimes we'll just use it in terms of those words. You can write it with the word to. You can write it success colon fail. So that's also 2. Some people do write it as success over fail as a ratio as well, like an actual fraction. So if you have odds, you can always find your probability and vice versa. It's just a little bit different. So if someone says, hey, the odds are 1 to 4, that means 1 time you win, 4 times you lose. So that means you would have played a total of 5 times. So we could figure out odds, but we can also get probability from that as well. So we'll talk about both as we do our examples. So I will add a little bit onto these examples so we can talk about that. All right, so let's take a look at some so we can actually practice. So we've got a box of marbles. Of course you have a box. It's either a box or a bag, right? We know all of our made up questions. Like you imagine people walking around the street with bags of marbles and you wonder why? Because they're going to do probability. No, it's because we want to have just easy examples, but kind of weird that we always do these. But we have all these different kinds of marbles in a bag or a box, whatever. If a marble is selected at random from the box, what is the probability that that is yellow? All right, so what we're looking for is the likelihood that the probability that you draw a yellow marble out of the bag. So the way I would write this, P for probability, and I would say yellow. This is the event. This is what we're looking at having happen. How likely is that event to occur? Well, what we have to look at is the number of ways we would draw a yellow then out of the total number of outcomes in that bag. So let's talk about the total number of outcomes here first. We have 10 different marbles in that bag, so it'd be out of 10. How many are yellow? Well, there are 2 of them, so that's the probability would be 2 out of 10. Now, often we'll reduce to make that easier, so 1/5. So you can write your probability as a fraction. Works great, 1 out of 5. So 1 time we get a yellow out of every 5 times we draw that out of the bag. Now, you could also, though, write that as a decimal, so 0.2. So you can write your probabilities as decimals. But then you could also write that as a percent, so that would be 20%. So we have 3 different ways that you can write those probabilities. It just depends on what's easiest for you to look at. So let's talk about odds then. How would we do odds? So odds that are yellow. So we already figured out probability. So if the probability is success over total, we want success to fail. So success to total. So that means we played 5 times, we won once, we got a yellow. That means the other 4 times we wouldn't. So the fails would come from doing the total minus the success. So we do 5 minus 1, so our fails would be 4. So the odds that you get a yellow would be 1 to 4. So remember that's success to fail. So if we win 1 out of 5 times, that means we won once and we lost 4 times. So you could write it with the colon, you could write 1 to 4, or you could write the ratio 1/4, but just realize that you're writing that as an odds, not a probability. So we can always go from one to the other. All right, let's try another one. This is a checkpoint too, so there's a different video you can watch as well. All right, so you're going to toss 3 coins. What's the probability all 3 land tails up? All right, so let's take a look at the first one. So what's the probability? Think about this when you flip a coin. What's the probability that you get tails? Well, it's 1 out of 2, right? So every time that's a 1/2. So we're going to do this 3 times, and we want to figure out what would the probability of that be. So on the first one, we've got a 1 out of 2 chance. On the second one, we've got a 1 out of 2 chance. And on the third one, we've got a 1 out of 2 chance. So if you remember the counting principle, we multiply those together. So we look at the total number of ways, and we would say on the first toss, I have a 1 out of 2, second toss, and the third. That's probably the fastest way for a lot of people to do that. So the probability that would happen would be 1 out of 8. Now, for a lot of people, they may not remember that counting principle idea. I mean, we've done a little bit with that. You could also list it. You could list all the different outcomes when you toss 3 coins. So like you could get a heads, heads, heads. You could get a heads, heads, tails. You could get heads, tails, heads, tails, heads, heads, right? We could go through all the possibilities, heads, tails, 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 heads, tails, all the different possibilities, tails, tails, heads, and then tails, tails, tails. And look through and say, okay, how many of these have all 3 that land tails up? There's only 1, so it'd be 1 out of a total of 8. So you can get probability in lots of different ways. So probability that we get 3 tails, you could do it as a list or you can just multiply. What would the odds be then? Well, if this is success to total, the odds would be success, remember, to fails. So if I played 8 times and I only won once, that means my fails would be 8 minus 1 or 7. So this would be a 1 to 7 odds. So we'll always do both so we can talk about both of those. All right, let's try another one. Let's try the bottom one. You draw 1 card at random from a standard deck of 52. What is the probability that it's a diamond? All right, so very similar kind of question. We have to think about what our possibilities are here. So I'm going to clear off the old stuff so we can do the new one here. So we draw 1 card at random. So I'm going to say probability that we get a diamond. So just describing that event. All right, well, how many cards in the deck are diamonds? Well, there's 4 suits, remember, and there are 13 in each suit, 52 cards total. So 13 out of the 52 cards in the deck are going to be diamonds. So we'd have a 13 out of 52, or some people just go right to this, 1/4, right? 4 different suits. So we'd have a 1 in 4 chance of grabbing a diamond. So that would be my probability. What are the odds then? Remember that's success to total. So the odds then are going to be success to fails. So if I'm playing 4 times and I lose once, that means, or I win once, I should say, I'm going to lose 3 times. So that would be 1 to 3. So you can always figure out odds if we have probability. So we're looking at how likely is it that something happens. All right, let's try another one. You toss 2 6-sided dice. What's the probability that the total is 5? So a little bit different. The total of the 2 dice is 5. So let's talk about that. What would that mean? Total of the 2 dice. So the sum is 5. All right, well, think about all of your outcomes, and this is really important. When you think about the outcomes, your sample space, remember that you're tossing 2 die. So that means you could get a 1 on the first die and a 1 on the second die. You could get a 1 on the first die and then a 2. You could get a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. But then you could get a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4, 2 and a 5, 2 and a 6, and so on, right? We could do our next list. So how many of those lists would we have? Well, we'd have 6 lists of 6. So that means on your die number 1, you've got 6 options, right? 6 different outcomes. On your die number 2, you have another 6. That gives you the total number of outcomes as being 36. So you have 36 total outcomes when you're doing this sample space. So I know my denominator is going to be 36. Now I'm going to keep listing here so we can talk about this. This is probably the easiest way for you to see how many different ways could you get a sum of 5. So I'm going to get rid of that for a second so I can keep going with the list. So if you look through your list of numbers, which ones would give you a sum of 5? Think about the combinations of your die that would give you a sum of 6. So sum of 5, sorry. So let's go through the list and see. So how would you get a 5? Well, you get it with a 2 and a 3. You'd also get it with a 1 and a 4. But we'd also get it with a 4 and a 1, and you'd also get it with a 3 and a 2. And those are the only ones. So how many outcomes give you a 5? Well, 4 of them. So you have a 4 out of 36 shot, which means it is 1 out of 9. So this idea of calculating probabilities, really look at your total sample space, what's success in that conversation. So sometimes making the list for these die examples are helpful because we can think about what those are. All right, let's try another one here. Lots of practice. The more experience you get, I think the easier it is to wrap your head around these. All right, so we're going to do a lottery example here, everybody's favorite. We'll do some lotto. Pennsylvania Cash, you choose 5 different numbers from 1 to 5, or sorry, from 1 to 43. So we're choosing 5 numbers, and we want to match in any order, so the order doesn't matter, to get that top prize. So what's the probability if you buy 1 ticket? So what's the probability that you win choosing these 5 numbers? All right, well, let's see if we can figure out what we'd be calculating here. Well, you're only buying 1 ticket, so there's only one successful argument here. There's only 1 ticket that's going to match. But we need to choose, so with the total sample space here for the denominator, we're choosing 5 numbers from 43 where the order doesn't matter. Okay, so is that a combination or a permutation? So if you think back to what we're doing with those, so combination, permutation, if order doesn't matter, it's a combination. So we're at 5 choose 43. So I'm looking for how many different ways. Oh my goodness, my brain is backwards here. 43 choose 5. Sorry about that. So we're taking 43 numbers and we're going to choose 5 from them. So we can figure out what that likelihood is. It's not very likely. So we've got a 1 out of, if you do that calculation, 962,598. Not super likely, but somebody's got to win, right? So if you think about what that would look like. So that's the probability. Odds would be, remember, success to fail. So it would be 1 to 962,597. Not great. So not great odds either. So it's just, again, looking for how many different ways is successful. All right, last couple of these and we'll go on to our last couple of comments here so we can finish up. We have it's a lot to talk about in this section, so 9-7's a pretty big one. So you're forming a 12-member swim team from 10 girls and 15 boys. Find the probability that, okay, so let's do the first one. The team must consist of 6 boys and 6 girls. So if we think about what that means for success here, we're going to do probability. We want to figure out what's success and then what's the total number of ways to choose. So the probability of 6 boys and 6 girls. All right, well, let's talk about success. I want to choose 6 of each. So if I look at there's 12 members, there's 10 girls to choose from, 15 boys to choose from. Order doesn't matter. You're on the team whether we pick you first or last. So of the 10, or we'll do boys first, I guess, because I listed it first. There's 15 boys to choose from, and I want to choose 6 of them. Order doesn't matter. And so multiply. I am choosing from 10 girls, and I'm choosing 6. So I'm doing 6 of each. Now that would be the success. That would be the outcome I want. In the denominator, what's the total number of ways to just choose 12 people from a group of, how many total am I choosing? Well, together, that's 25 kids altogether. So it would be 25 choose 12. I'm going to have you pause the video, take a moment, do your calculation. But remember, the 2 numbers that you're choosing on the top should always total to the number that you're choosing on the bottom. So when we put that together, big numbers. And then you have to really have the conversation, what makes sense? Do I want to try to reduce this, or really is it going to be better to write it as a decimal, which might be an easier way to do that, which is about a 0.202. So it's about a 20% chance that that's going to happen. All right, probability at least 10 boys. The team has at least 10 boys. Now remember, you're forming a 12-member team. We want at least 10 boys. So what would success be? Well, that would be 10 boys and 2 girls. Remember, we have to make 12 people on our team. But you could have 11 boys and only 1 girl, or you could have all 12 boys and no girls. So all of those would be success. So I need to think about all of those probabilities together. So all of these would be successful outcomes. So the probability of at least 10 boys, I'm going to have to add some things up. My denominator, though, is going to be the same because the number of ways to choose 12 people from a group of 25 remains the same. So that denominator is the same, but my numerator has to be 10 boys and 2 girls, or 11 boys and 1 girl, or 12 boys and no girls. So let's see how we would calculate that. So I have 15 boys to choose from, and I'm going to choose 10. And at the same time, I'm going to have 2 girls being chosen. So 10, choose 2. If I just did that, that would be the number of ways to do 10 boys, 2 girls. Or, though, we have more than one way to be successful. So or means add. I'm totaling up all the ways I can be successful. If you're saying the word or, you're adding. I could do 15, choose 11 boys times my 10 girls, choose only 1. So that would be 11 boys, 1 girl. Or, so plus, let's do the last one, the 12 and 0. So I would do 15, choose all 12. Technically, you could say 10, choose 0. 10, choose 0 is always 1. How many ways can you choose nothing? One way, choose nothing. So you wouldn't really have to write that, but sometimes people like to see what that value is. All right, so let's take a peek and see what that value is. Our denominator, we had that same number we did before. And then we can go ahead and simplify from there. So that bottom number was the 52. And then take a second, pause the video, go ahead and calculate in those and sum them up so you can see what the total is. All right, which is about, and again, it might be easier to think of this as a decimal, almost 3%, so just a little under 3%. So not very likely, much less likely than it was to have 6 of each. All right, so that kind of ends our first chunk of this. This is that section 1. So I'm going to go ahead and end this video, and then we'll do a part 2 for the mutually exclusive and inclusive, so we can talk about that part separately.